Hey, welcome back, you guys. I hope you had an awesome break. This is a little bit of a review. In fact, if you would like to try it without me, you could probably fast forward to spots on here where I showed you the answers. I mean, you're going to see if you fast forward them appearing below. And see if you can handle it. There's a few tricky problems in here, but we don't have too many problems to get done on here. I think it's just 2 pages on 6.4, so I'm gonna shoot through this with a relative speed, and hopefully it's stuff that you review. But I'm gonna verbally say it as we go through. So if you remember, and all these require, the very first thing that we always do is factor out the greatest common factor. And if I look through here, it looks like each one of these has an x. And I think there's another, so no even number goes into 15, but I think 3 goes into all of these. So I've got 3x right there. And if I pull 3x out, I've got 2x squared, that's 6 divided by 3, x cubed divided by x. And as I go across, I get 5x, and then this is just 2. Well, the AC method would be saying, hey, since my leading coefficient's 2, there's other ways to solve this. It says, hey, what multiplies to 4? And adds up to 5, and most of you probably realize that's 4 times 1 gives me 4, and 4 plus 1 gives me 5. So I'm gonna add another. I'm gonna keep that 3x here, but I'm gonna put like a bracket there so I can separate this. So my 2x squared stays the same, and this 5x is gonna split into 4x. Let's put that in parentheses, and just 1x. Alright, and now we're going to factor by grouping in here. So we got 3x, this turns into 2x, which turns into 2x squared divided by 2x is just x. 4x divided by 2x is 2. And since that's already x plus 2, we can factor out a 1. Alright, so I still have this factor of 3x. These numbers are my other factor, 2x plus 1. If I took out the GCX of there, GCF, greatest common factor, I'd have x plus 2. Alright, so that one's done. You're going to love this next one because it's quick. 2 goes into both of those. It looks like x goes into both of those, which gives me x squared minus 10. You might think, since that's a perfect square, that you could factor this again. You really could, right? You could say x minus rad 10, x plus rad 10. But since we're looking for integers, we're going to stop right there. And that's irreducible for integers. And we're going to keep going. So this guy right here, once again, I got a GCF. Looks like x comes out of there. And that gives me 3x squared plus 7x plus 4. If I'm thinking about it, AC is 12, right? 3 times 4 is 12, and adds up to 7, which looks to be 3 and 4, right? 3 times 4 is 12, and 3 plus 4 is 7. So I'm going to split my middle term. Let's go ahead and put a bracket in there. We'll say 3x squared, and that 7x becomes 3x. Let's put that in parentheses. And 4x. We'll put that in parentheses. And let's go ahead and factor what? 3x out of here, which gives me x plus 1. And maybe 4 out of there, which gives me x plus 1. Alright, so I've got x. This is 3x plus 4. And this is x plus 1. Forgive this, I got a little bracket in there. I can make it a little rounder. I should have just done parentheses, but those are my 4 factors. Let's go ahead and box this answer so we know it's the answer. Let's come back here and put a little box around that answer. So that was the AC method and GCF. These are probably the hardest type of factoring that we're going to have. You can see the special situations we come down here. The 2 easy ones, and these are already on notes that you have, the difference of the square, right? The only binomial that factors into a sum and difference to other binomials, right? A perfect square trinomial. We've recognized this pattern before, right? And then we have the sum and difference of cubes. They're our only new note, and you have notes on them. So I'm going to do a couple down here just so you can see the sum and difference of cubes. These are going to be the new ones. There's going to be cubes in here. All right. So your goal is to kind of identify A and B. So if I identified this, That would be, well, let's rewrite that. 27 is 3 cubed. So I'm going to put that 3x and put the cube on the outside. All right, 3 cubed is 27, x cubed is x cubed. 64 is 4 cubed. What that does for me is it allows me to recognize that my a in this situation is 3x. And if this helps, cool. My b is 4. Then I can kind of follow this pattern, right? That's a and b. And this says, hey, if there's a plus sign, do a plus b. So that would give me 3x plus 4. And then we got a squared minus ab plus b squared. So a squared is 9x squared. Multiply those together with a minus, so we got minus 12x. And then that squared is 16. Right? And I'm going to stop there. All right. Ooh. Yeah, I stopped there. Nothing factors out of that I can think of. So I'm going to come back and do this guy right here. All right, so we've got 8x cubed minus 27. I could rewrite that as that quantity 2x cubed minus 3 cubed, which means in this case my a is equal to 2x and my b is equal to 3. Let's write that down here to get some more room. So if I follow this one, that's a minus b. So we've got 2x minus 3, and a squared, which is 4x squared, ab, which is, these are all plus signs with this. From here on, everything's a plus sign, so that's 6x plus 9. I can't think of anything that multiplies to 36 and adds up to 6, so I'm done factoring. All right, I'm gonna do the same thing here. All right, I'm gonna take out a 5x, and that's gonna give me 8x cubed plus 1. I'm going to point out what your a and b is, and I would like you to do this. So my a is going to be 2x, because that's a perfect cube plus a perfect cube, and my b is going to be a 1. I'm going to highlight that. All right, you highlight that too, so when I go through and search that you did some on your own, I'll be able to tell that you did this one, and you came in and you compare that tomorrow with your partners. All right. And I don't think there's anything too tricky with that. It's kind of just following the format. We got a little bit on the next page. So this one's a little tough in here. There's a couple in here that are kind of tough, and a couple that aren't so tough. So I guess if I said a couple and a couple, that would imply there's 4, and there's really only 3 here. But it's factoring by grouping. For the most part, factoring by grouping is pretty straightforward. But there's a tricky problem on here, so I'm going to walk you all through all these problems. Looks like the GCF here is x squared, which gives me x plus 1, right? X cubed divided by x squared is x. X squared divided by x squared is 1. Now this is already x plus 1. We still have to get that common factor out, so we bring out a 1. And that GCF of x plus 1 factors out, x plus 1, and that leaves me x squared plus 1. Resist the urge to keep factoring that. That is not a minus. Even though that's a perfect square and that is a perfect square, it's a sum. So at this point, we are done. We just kind of say we're done with that. Do the same thing down here. So let's group them. Looks like x cubed comes out of here, right? X cubed comes out of both of those. That gives me x plus 1. All right. And that's already x plus 1, but I have to factor something out. That gives me x plus 1. I get this. I get x cubed plus 1 and x plus 1. And I notice that that is a perfect cube plus a perfect cube. So this portion right here factors into cube root of that is a, cube root of that is b, plus b. If this is hard for you, look on the previous page. This squared, x squared, multiply them together, plus x, plus this squared, plus 1. And then I've already got this x plus 1. So this factored into an x plus 1, and there's an x plus 1 here. So I'm going to put just a square there, because now there's going to be 2 of them, right? Now, this last guy is tricky. And I'm going to start you off on it anyway. If I just try to factor this, it isn't going to work, right? If I just try to factor this, will come out an x squared, which would give me x plus, 3? And there's no way I'm going to get an x plus 3 out of that. So when you see this, in a situation like this, try to factor this so something comes out. You can split this term and bring over here. Like, what if I brought one of the x squareds over here? Well, then I can think of something that multiplies to 2 and adds up to 3, and I think I can factor that further. So let me show you what I'm talking about. I'm going to keep my x cubed. But I'm going to take that 3x squared and write it as 2x squared plus x squared. So this portion is still here. There's still my x cubed, and that's my 3x squared, right? These guys make 3x squared. Let's drop down the rest of this. Plus 3x plus 2. So we have to figure out a creative way to group these. This, I can think of things, leading coefficient is 1. I can think of something that multiplies 2 and adds up to 3. So that's 2, right? And 1. So that factors like that. This portion factors. And this, well, let's take out an x squared, and that gives me x plus 1 as well. Let's put a plus sign in there. So what you can see is this. You can see that there's really an x plus 1 in both, right? That's my GCF of the left, right, and the right. So I take my x plus 1 out, right? And what's left is literally, if I take those out, right, I've got x squared, right? So I've got x squared plus x plus, what do we got? 1, just like that. So it looks a little tricky. And I don't think I did anything wrong here. Let me check. You know what? I did make a mistake. I made a mistake. I apologize. I'm going to go back and fix this. Right there. Do you see what happened when I factored out that x squared? Someone's probably already caught me, and you're saying, get with the business, Burkhart. But that leaves me x plus 2 there. All right? And now my common factor is x plus 2. X plus 2. And when these come out, so that comes outside, that leaves me an x squared plus x plus 1. And now I'm done. That's kind of tough to see, right? If I multiply this back in, like from this, I brought this to there, that would be x squared times x plus 2. If I brought this to there, right? If I brought this all the way inside, right? That would also be x squared times the rest of times x plus 1, which we see over here. All right. So you guys have an awesome, awesome, awesome day, and let's get back to this. I'll see you tomorrow with this work done.